The first type of wave is a transverse wave. It can be electromagnetic or mechanical. The second kind of wave is a longitudinal wave. These waves are mechanical only. This is a transverse wave. The symbol at the top stands for the wavelength or the distance between two crests. A crest is the tip of a wave as labeled. Amplitude is the distance from the center of the wave, marked by a blue dotted line, to the crest or trough of a transverse wave. The trough of a transverse wave is the bottom tip of the wave as labeled. This is a longitudinal wave. The wavelength is now the distance between two compressions or bunches in the wave as labeled. The spaced out sections of the wave are called rarefractions. I'm showing the relation of wavelength, frequency, and velocity of a propagating wave. You will need scissors, yarn or string, something heavy or fixed to tie the string to, and a meter stick and a stopwatch if you have them. You will need to cut the string and tie it to the fixed object. Then record yourself shaking the string at different speeds. You could slow the video down or pause it to measure wavelength. In order to do so, you would need to be holding a meter stick parallel to the string while recording. You could then measure the distance between your hand holding the string and the fixed object that it is tied to, and use a stopwatch to see how long it takes one crest to go from your hand to the pole or the end of your wave. Then divide the distance by the time to find velocity. Repeat this for the different speeds of waves. After performing this experiment, you would find that wavelength and frequency are inversely related. This is due to the equation shown. Velocity equals wavelength times frequency. This experiment can be shown much easier using a slinky and a meter stick, but we had neither at my house. The background for the video wasn't ideal either. The demo was hard at first because getting the yarn to make a clear wave was awkward. It would have been a lot better if I could have held up a meter stick to show the distance. Mechanical waves require a medium to pass through, such as glass, water, or air. Because solids are most dense, mechanical waves travel fastest through them. Liquids are less dense and therefore mechanical waves travel slower through them, however, still relatively fast. Gases, being the least dense medium we study in this class, have the slowest speed for mechanical waves. The temperature of the air does affect the speed of the wave. Hotter air contains higher kinetic energy, and waves travel faster through it than low kinetic energy, cold air.